Greetings everyone. Today our team will be presenting on anomaly detection and quality control. The team consists of me, Aiman, Atira, which has done the Excel charts for quality control, Natasha, which has done the linear regression using R programming, and me and Yap will be the presenters for you today. As an introduction, we are given a scenario where we are part of a team of data analysts which are working for a manufacturing company that produces heavy vehicle parts, and they are concerned about maintaining their product quality among many others. So in this project, we will cover key aspects of our solution, highlight the main findings, and analysis techniques and recommendations for this project. We are also going to acquire proficiency in utilizing control charts and determine if it is in control or out of control. Other than that, we will also use R programming to perform linear regression analysis to show the relationship between the dependent variable and the independent variable as a linear equation. And in this one project, we are given a sample of data which consists of 80 samples and 3 parameters. And our task is to ensure that we can analyze the data, propose some recommendations for it to enhance the process, and address any quality control issues. Based on the scenario given, we also have a few objectives to accomplish, such as to apply statistical quality control analysis to monitor the defects of the heavy vehicle parts so we can improve the product quality, or to identify the steps which can enhance the quality control processes, which can be done through learning about quality improvement strategies. To give a brief summary on some of our data, here they show the quality control on length and operators, which is operator 1, 2, and 3. So, to highlight the data here, the figures of the X chart from R and R chart show that the process is under control. However, the X chart from S and S chart, where the X chart from S and the data have reached beyond the upper and lower control limit, which can be concluded that this data is out of control. And these are the graphs for the other parameters, width and height respectively. So for the width graph, we can see that the X from R and S are out of control, while their respective R and S charts are in control. And as for the height parameter, the X from R and S graphs are out of control, while their respective R and S chart is in control. The methodology for calculating the values in the control charts, either from X, R, or S control charts, are by using the formula shown right here. So we can see that there are various formulas to be used, and we will input these formulas in the Excel after we have inputted all our data, and we will proceed to make a graph from the Excel program.
We actually had employed multiple tools for our analysis. Other than utilize control check in Excel, our team members Natasha have utilized our programming to conduct linear regression, yielding similar results to those obtained through the control chart analysis. The first chart displays the width and height measurements for all three operators, while the second chart specifically focuses on the measurements from the first operator in terms of height and width. Based on the provided data for operator 1, clearly with the height versus width measurements, the p-value, which in this case is 0.390041, which is a crucial factor to consider as it shows the goodness of the fit of the model to the data. From this, we can conclude that there is no significant positive relationship between width and height as our p-value is equal to 0.390041, which is larger than 0.05. Two of these charts display the data of operator 2 and 3, specifically in terms of height and width. Based on the raw data for operator 2, particularly the height versus width measurements, it's important to highlight the significance of the p-value. For this run test, the obtained p-value is 0.517. Therefore, we can conclude that there is no significant positive relationship between the width and height because the obtained p-value, which is 0.157, is larger than 0.05. As the result of the regression on three operators were all not significant, you can say that all the parameters that had been recorded are dependent parameters. They will not affect another parameters as they increase or decrease. Therefore, we can conclude that all the chart that has been shown is abnormal. In conclusion, operator 2 has the closest value to the control limit. This means operator 2 has the most accurate parameters to produce the heavy vehicle parts, as operator 2 also a good quality operator compared with another two operators. In a nutshell, operator 2 can be considered in maintaining the product quality while optimizing the process to improve the product quality. Actually, we can make quality control chart using RStudio, and these are the example of X bar chart and R chart of operator 1 by using RStudio.
Thank you.